And so when looking at the slope formula, we're going to kind of bridge the gap between the graph and the formula, and then afterward we'll do a simpler version of the formula. To find the slope of the graph, Aiden chooses these 2 points. And he says the rise is 2, the run is 6. And so if we have that, then we can simplify that to 1/3. Okay. Now, which values in the ordered pairs? So before we were looking at the graph, we're going to look at the graph to help us move to the points, and then we'll just have points later. So when looking at those 2 points, 3, 5 and 9, 7, how could I get a rise of 2? What values could give me a value of 2? Which values from the ordered pairs could give me a rise of 2?
5 and 7.
Why 5 and 7?
Because the 5 rose to 7.
Okay, and if I was going to subtract them, the only way to do that would be 7 minus 5 to give me a positive 2. And that is because these are y values, and we had rise. So rise falls to y values. And on the board over here, we see vertical, y, up and down, rise, all mean the same thing. So if you see those things, they're all referring to y. So what other values in the ordered pair could give me 6?
3 and 9.
Okay, but 3 minus 9,
9.
right, so it'd have to be 9 minus 3, because otherwise I would have a negative value, and it's not negative. And it's also an x value. Okay, and that's the run. So what other things are associated with run? Horizontal, x, left and right, run, all of those go together. Now, is there anything you notice about these 2 pieces and these 2 pieces?
Yeah, less.
Okay.
The fractions
They're from the pairs. The 7 and the 9 is from a pair, and the 5 and the 3 are from a pair.
I knew that.
Okay? So when we do these problems, whichever number is first here, its partner has to be first here. Okay? So whatever comes first in the y, that partner x value must come first as well. And so that formula is given by this right here. M equals change in y over change in x. And from now on, this means slope. Okay? So anytime you see the letter M in here for the next several weeks, it's going to be considered slope. M is slope. Change in y over change in x. Well, that's what I'm finding by taking y2 minus y1. This is the change in y, and this is the change in x. Change in is just a subtraction problem. Okay, so once again, we're going to look at a graph and use that to bridge the gap back to points. So what is the x value and y value for one of the points? Right here? 2, 2? That's on the line?
3, 5.
3, 5?
Oh, I was looking at the wrong thing. And then 6, 3. 6, 3.
and 6, 3. And you could do 9 and 1. You could also do 0, 7. But since you guys said 6, 3, and 3, 5, we'll go with those. So this is where it becomes a little bit tedious. I have to label my points. Okay, I have to label the x1, y1, x2, y2. So x1, y1, x2, y2. So according to the formula, we have 3 minus 5 over 6 minus 3. Okay, so I'll highlight this is here, and this is here. It's first in both the top and the bottom. They came from the same place. They had to be in the same position here. And then that's also true of these values. They were both second. Okay. So what's 3 minus 5?
-2. I thought we put
And what is 6 minus 3?
3.
Okay. And so what was your question?
wait. So the x2 is going for the x1.
I mean, that's what it says here, right? Okay, now, yeah, we'll get to that in a second. Okay, now we could verify this by just counting, right? So 2, 3, and the slope is negative, so that makes sense. So if you're given a graph and it says use the formula to find slope and the answers are slopes, what are you going to do? Let me repeat the question. If you have a graph and they say use the graph and use the points that are on the graph to find the slope, what are you going to do?
Use the points on the graph to find the slope.
Great. But, I mean, which method would you use?
The triangle.
No, don't use this. This is way too long for counting. Okay? So, the reason we're doing it here is because we want to show that there's another way if you have points. But if you're ever given a graph, don't do this. Just count. It's way faster, way simpler. Don't do extra work for no reason, right? Okay, so if you're given a graph, don't worry about this. Just count. Okay, but down here we're not given a graph. So, first thing to do is label your points. x1, y1, x2, y2. So try to solve this one real quick, and then we'll check it. Okay, so let's look at this real quick. 2, 4, right? 2, 4, 7, 1. So 7 minus 4 over 1 minus 2. And you get 3 over negative 1. And then some people I saw did 4 minus 7 over 2 minus 1. And you get negative 3 over 1. So the order actually doesn't matter as much as the formula would like you to think, because what if I decided at the beginning to call this x2, y2, and this x1, y1? Who would know, right? What if they were given to me in the opposite order? Well, it turns out it doesn't affect the slope. The slope is the same either way. Okay? Now, that we've done this the difficult way a few times, I'm going to show you a much faster and more simple way to do this. And it's 3 simple steps. Stack, subtract, y over x. So I'm going to take the points negative 1 and 3, and 5, negative 5. I'm just going to stack them on top of each other. So write the 2 points down, stack them on top of each other, and then subtract. What is negative 1 minus 5? Negative 6. Right? Negative 1 minus 5 more, so we're adding that negative 5 in. Okay, negative 6. And here's another tricky one that you have to remember, some identities with negatives. 3 minus negative 5 is 8. So we now have an x and a y, and the rule for slope is y over x. And so the steps again are stack, subtract, and then y over x. And so if we do this again, 8, 11, 11, 10, 22. What we care about is change in y over change in x. Well, that's always a subtraction problem. So subtract. 8, 11, 10, 22, and subtract. So what is 8 minus 10? Negative 2. And 11 minus 22? Negative 11. And so we do y over x, negative 11 over negative 2 equals m. And of course, we all remember that a negative divided by a negative
Is a
is
positive.
a positive. Okay. So now we're going to look at some fast ways to do specific ones. There's 2 special cases. What were those special cases from a graph? There were 2 special cases on a graph. What were they? There are 2 special cases on a graph. What kind of lines? Andy? Horizontal and vertical. So horizontal is always 0. Vertical is always undefined. So what does that have to do? What does that have to do with the x value not changing in this case? Yeah, the x value does not change.
So I write that too.
Uh-huh. So if we have a graph, if we have points where the x value does not change, think about that visually. The x value isn't changing. Negative 1, 9. Negative 1, 6. Negative 1, negative 1. What kind of line is that forming? A vertical line, and someone already said it. M equals, well, it's undefined. There is not a defined slope. The slope doesn't exist in this case. It's undefined. So if the y values didn't change, the slope would be 0. Okay, so those are kind of opposite of each other. X values don't change, undefined. Y values don't change.
0.
Okay, U and D, undefined. Okay, number 2. What's the difference in a table and points? Nothing.
Can't count the point.
What?
Yes. Funny, you can't eat off of a point. Okay, but with a table, you have more options. Okay, you have more options. So I can pick any of them in any order. It doesn't matter. So I can pick any of these in any order. It doesn't matter.
0, 5, and 2, 6.
So 0, 5,
26.
2, 6. So a stack,
Subtract.
subtract, y over x, that's a fact.
What?
I'm just trying to make it rhyme, you know. 0 over 2 is negative 2. 5 minus 6,
Negative 1.
negative 1. So I have m equals
1. Negative
1 over 2 because they're both negative, which means it's positive. Okay, just to prove the point though, 3, 6.5, and 0, 5, and I subtract. 3 minus 0 is 3, 6.5 minus 5 is 1.5. What's 1.5 over 3? It's the same thing. So you didn't have to write this example. I'm just showing you that the two of those are equivalent. Okay? Okay, I just want to show you they're equivalent, right? It didn't matter the order, it didn't matter which points, they're equivalent. Now, number 3 we don't have to do because the slope is what?
0.
Why is it 0?
Because y does not change.
No change in y. No change in y. In other words, I have a point and another point and another point and another point, and they're all at the same y level, so they're not changing. Point, 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 point. It's a horizontal line. Okay, so a web designer charges customers an initial consultant fee plus an hourly rate. The table shows that relationship. Okay, X is hours, Y is the total cost. We want to find the rate of change, which is just a fancy name for slope. Rate of change, fancy name for slope. So, pick a point. No.
5, 8.
10, 7,
5.8 isn't a point.
2,
5, 400.
5.
5, 400.
I think 500.
I said that.
And what's another one?
10, 7, 10, and then 729.
Okay, and then we subtract. So 5 minus 10, negative 5. 400 minus 725. Okay, so when we subtract 400 minus 725, we get negative 325. Okay, now y over x, negative 325 over negative 5 should be positive 65. So what does that mean, though? Positive 65 means what? That he makes 65, I forget. He makes $65 an hour.
That's really good.
That's roughly like $130,000 a year. Okay, we're gonna skip number 5, and the reason we're skipping number 5 is because it simply says, here's a point, here's a point. So we would just do what we did again and repeat, and so I'm gonna skip that. Okay, so these kind of interesting triangle questions are liked by the STAR people a lot for some reason, and I'm not sure why. But Yin and Jude each choose 2 points. Here, 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 and here. And so Jude, use Jude's points to set up and simplify the slope. Are we going to do that? No, we're going to count. 2, 3. So it's rise over run. And what kind of line is this?
Negative.
So negative 2 over 3. Remember, if we have a graph, we're not going to use the formula. That's a waste of time. And then, what is the slope for the other one? Well, count up and over. And what do you get?
6 over 9, negative.
6 over 9. And it's the same downward slope. So negative 6 over 9. Okay, is everybody okay with counting up, down, left, and right? Okay.
No.
So, if you see a graph, don't make it hard on yourself and just make it easy by counting left, right, up, and down. Okay, how are these 2 things related to each other?
They equal the same.
Because if you simplify it, it equals the same thing.
Okay. Yes, that's more of the answer to D. So we'll answer... we'll do both. Okay, we'll say that. So they're how are they similar to one another? Well, they share. Oops, that's not how you spell they. The same slope. They share the same slope, and their long side is on the line. If that's not true, if they both don't have the long side on the line, then they would not be similar. They have to have the hypotenuse, or the long side of the this side is shorter, and this side is shorter than the third side here. That's the longest side of the triangle. That doesn't look like that.
That's a sloped triangle.
That's also a triangle that doesn't look like that. That's also a triangle that doesn't look like that. So there's like an infinite number of ways we can get triangles that don't look like that. Okay, and what can we assume about the slope? It's always the same. So if you have 2 points on the same line, the slope is always the same. Always, 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 always the same.